Uh, so today I'm going to be talking, hopefully not for too long, about map and reduce in JavaScript, though the concept of map and reduce does extend out to quite a few other languages. Lots of languages have it to a greater or lesser extent. Yeah, I'll be talking about it in JavaScript, just because we don't talk about JavaScript as much as we possibly should do, as we are a website. So a bit of a recap to begin with. Who was here actually for my talk on closures? Yay, quite a few. Good. So I'll just have a quick recap of some functional concepts. The idea of functions as a thing, what it means for a higher order function. Then we'll get on to map, which is really quick, because map is really easy. And then reduce, which is a bit more complicated. The concepts, people sometimes have a hard time getting their head around it. Hopefully, I've found a way of explaining it, which is a bit clearer. And then just finish up with, some sort of more complicated examples of map and reduce working in tandem. Then maybe moving on to, depending on time, any limitations there may be in JavaScript, and how they can be addressed using a third-party library called Lodash. So, first of all, functions as a thing. Quite an important concept in JavaScript is that functions are actually objects, just like lots of other things, and can be treated as such. So whilst functions can be declared, as you'd expect in lots of other languages, X. That's how you'd expect a function to be written normally. It's a function, keywords, name of the function, declaration. That's not actually the preferred way of working in JavaScript. The preferred way is to actually declare the function anonymously and bind it back to a variable. So you can see from that we've got an anonymous function, and it's just been assigned to a variable called square, and that can be treated just like any other variable. It can be assigned to other things, and then actually called when you're ready to use it. So a function is just another thing. It can be passed around like a variable. It can be executed. Pretty straightforward. Everyone clear with that one? Everyone happy with that? So this actually leads on to the next bit, which is, to recap, a higher order function. Because a function is just a thing and can be passed around, that also means that functions can themselves either take other functions or return functions. So do I have? I think I have. I quickly hammered out example of that. Can I copy and paste? Wish I brought a mouse with me. So yeah. Yeah. Put that in there. Got a little example. So here I have a function called power, which returns a second function. So this one I gave as an example, I think, last week when I was talking about closures. We've got a function called power here. You can see I'm calling it here. Power 2 gives me a square, and power 3 gives me function cube. So I can square 2 there. And the fact that square and cube, one is something multiplied by itself, and then the other is something multiplied by itself, multiplied by itself. You can see there's a very common structure there, and I've abstracted away that into a function called power, which builds up from that first argument another one. This was actually what we covered in closures last week. Can people see what that's doing there? So the inner function here, your passive value gets stuck into an accumulator, and then that is then looped around a certain number of times, depending on the outside argument, to decide how many times it's multiplied by itself. So we can easily power things by squaring them, cubing them. or an arbitrary amount. I could easily just go power 4. So 2 to the power of 4. Boom. 2 to the power of 4 is 16. Straightforward enough? Okay. I wish I brought a mouse with me. So, can I just, yes I can, just fold that away outside, out of minds. Move down to map. So, oftentimes, when you're working on stuff, you will have a list that you want to apply a function to every item in the list, or an array actually, because we have arrays in JavaScript. And you're probably all actually used to this, because you probably use link with select, which is basically almost a map. Well, it is a map, but it also encompasses something slightly different called a monad, but I'm not going to go into that. So if I was to have an array of a few values, what I can do then is I can map so if I run over an array and I map it, I pass it a function. Because map is a higher order function, it takes the function. In this case it takes a function which takes a single argument, and it applies that function to every item in an array and produces a new array. Just evaluate that. You can see there it has evaluated this list 1 to 9 to a second array of the squared values. And that's all that map is. It's really, really straightforward. Hopefully it's a really simple concept to get, but it's very useful for transforming one set of data into an equivalent set of data with a one-to-one mapping, applying functions to everything. And that is all the map is. Like I said, it's really straightforward. You've seen something very similar with C#, which is select, which allows you to go over any sort of arbitrary collection, applying a function to everything in it. Like I said, it encompasses something slightly more complicated than straight-up mapping, but it's mostly the same. So on to the one now, which is actually going to possibly confuse people more, or which is more complicated to get on this, which is reduce, also called fold, also called accumulate, also called aggregates, depending on languages. Unfortunately, they haven't really settled on a standardized name. They've settled on a couple of standardized names. It's most commonly called either reduce or fold. I think fold is what it was called originally back in the days of Lisp, and should probably be the more historically accurate one. First up, does anyone think they know what reduce does or how it works already? Also called aggregates, a less powerful one called aggregates in C#. No one's hand's going up. There's a sort of wavy sort of ish. All right. So reduce is for a separate. So perhaps if I actually just go, yeah, let's see. If I just define a function here which takes 2 arguments called add and does, well, what a surprise, adds them together just for a really numpty function here, a function which takes 2 arguments, adds them together. And if I just show a quick example, anyone want to take a wild guess what this might do? So what reduce does, is it takes an array. No, it doesn't. It takes a function. Sorry. Or let's see. It starts off with an array, a function that takes two arguments, in this case add, and an initial value here. So initial value is 0. And what happens now is it goes through every element in that array, something called the accumulator gets passed in as that first argument to the function, and the accumulator starts off at 0 here. So that bit there on juice, that is the initial value of the accumulator, so it starts off being 0. And now it steps through every item in the array, passing the accumulator and the current value. So to begin with, the first call to add will be for 0, the value of the accumulator, and 1, which is the first item in the array. And then this function is returning those two added together. Now what gets returned gets put into the accumulator, so it becomes the new value of the accumulator, and it goes around again on the next value from the array. So it literally just steps through each item of the array, and the result of each call to the function gets put as the new accumulator. So common things you might see from this are, yes, sum. In C#, there's the sum operator on a list, which is literally doing a reduce, where it's just adding all the items together. Other ones you might see are min and max, where the accumulator starts off at, say, well, with the first item on the list, and then it just steps through the list. Stop calling it list, call it array. That's what we've got here. You might do min and max, where it steps through each item on the list, just checking whether it's bigger or smaller than the accumulator, and replacing the accumulator with it if it is. And that ultimately will give you the minimum value of in an array or the maximum value in an array. So you can see, hopefully, that it's a really straightforward idea. Just steps through an array, applying function, and reusing it each step through. Does that make sense to people? Does anyone have questions on that one?
So what the result is 45?
Because it is 9. It's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8.
I look at this after being mapped to the square one. I thought, because the biggest one is
let me delete that because it's irrelevant, and maybe that makes it clear. And obviously here, adding two things together is so straightforward that it's a really numpty, stupid function. So oftentimes, for something simple like that, instead of actually making a function, which is so stupidly simple, which we probably won't use elsewhere, you can just write it inline as an anonymous function. But yeah, that is reduce.
It's strange name.
It's a strange name. I think it's because it's to get across the idea that what you're doing is you've got an array and you're kind of aggregating it down, reducing it down to a single final element item. So yeah, it's like fold is a funny one as well. What are you doing? It's like folding, really? I can sort of see it folding back in. Each one's getting folded back in on itself with a function used. But it's still a funny choice of words. It's not. If anyone can think of a better name for it, maybe that's why there are several different possible names, and people like fold, accumulate, aggregates, because no one's really settled on the one that they feel totally, my voice is going, totally comfortable with. Obviously, adding everything together is a really simple demonstration of reduce. So I've got a couple more examples of it, which will hopefully demonstrate a bit more of what you could do, what's possibly a bit more powerful. So let me just grab. Let's take. This here. So, this bit here maybe looks slightly familiar to some people. Anyone who's come through an interview fairly recently might recognise this, or has attended a Friday afternoon Casa.
What is it?
Check out Casa.
What's that? Sorry, move on.
Right, I'm going to review you before you start doing interviews again.
Don't know what it is.
Right, check out Casa. Is a very simple Casa we sometimes do, which is to do with taking a bunch of stock keeping units, equivalent pricing details, and when someone scans in a bunch of product details, you get the correct price added together. That's half the problem. That's really simple half of the problem. The more complicated twist comes in that there's also some special offers that apply when you hit certain numbers of scanned items. But the first half of it is actually just working out the subtotal. So, to sort of take this apart a bit, let's just copy this one out. This subtotal function is composed of two parts. First up, First up, we've got a scanned SKUs, which is just an array of SKUs, stock keeping units. And we have a JavaScript object there with the prices. And so I'm just doing a very simple map here, mapping the list of scanned SKUs to the prices. So I've transformed the array of SKUs into an array of prices. Really simple. And then for the second part, I'm actually then taking those prices and reducing it with a function which adds two things together. I've actually taken a slight shortcut there, in that I haven't bothered with an initial value on that one. Something I didn't mention about reduce is that you can actually skip giving the initial value, in which case it will just treat the first item off the array as the initial value. But I thought I wouldn't demonstrate it that way first, because that's the way people always demonstrate it first, but it then, I think, complicates it with what's actually going on, because it makes the first item in the array a special case now of, if you don't have an accumulator, it is the accumulator, and then it skips on to the second value, so avoid that confusion. So putting it all together into the subtotal function, and then, whoops, not actually calling it. And SKUs. Try that one again. Try that again with the right thing. Find it doesn't do anything. Why isn't it doing something? Oh, it is doing something. Yes, it absolutely does. You're absolutely right. Try again. So yes, passing in these price details and the SKUs. Nothing will happen for some reason, because I must have broken something somewhere. Where have I broken something? My random mashing of the keyboard there somehow ended up in there. Try that one again. That's better. So yes, my subtotal function now takes a list of SKUs and price details and actually gives me the subtotal. Actually transforms it to the price and then reduces it to the actual price. That's really straightforward. The second part of the checkout Casa then involves a list of, in fact I will grab it out from my prepared earlier example. Alright, so I have a function called aggregate tallies. Very easiest to demonstrate what it does by actually just running it. Oh. So this is taking the same array of SKUs as we were using before, and it's applying a reduce. And why isn't it done anything? Have I broken things again in new and interesting ways? No. Oh no, just taking a little minute. I have broken it again somewhere. Oh, it's decided to randomly do that again. That's better. Oh. Ah. So I can get tallies done. That's interesting, you set. Disappear. So aggregate tallies is a function that takes this list of scanned SKUs. Inside, I've declared a second function here. It takes collection SKU, and I'm doing a reduce using this arrow increment and a empty JavaScript object. And what it does each way through, it takes each SKU in turn along with the original collection, accumulator. It checks whether or not the accumulator has, so the accumulator is just a JavaScript object, it's empty to begin with. First up, we just check whether it has own property SKU, which is just checking whether or not that object has a property on it with that of that name. So first way through, if the scanned SKU was an A, it would check whether this JavaScript object had a key on it called A. If it does, it just increments whatever the value is on that key. So to begin with, else it makes a new property on that collection and assigns the value 1. So first time through, we'll take that first thing off of the scanned SKUs, which was, for example, say an A. We check whether or not the accumulator has a property A. It doesn't. It's an empty object to begin with. So it doesn't. So it actually makes that property A and gives it the value of 1. Then it goes to the next item in the list of scanned SKUs. Let's say it's the second A. Does that collection have an A? Yes, it does. Excellent. We'll just increment and assign that one there. So A now would have the value of 2. And in each step, we're returning the collection. So you can see now it's reduced that array of strings of SKUs down into a JSON JavaScript object with the tallies. So you can see there's 4 A's, 1 D, B, and C. That's the first step in then going through and doing the special offers step, where we first need to know, well, exactly how many of each one have been scanned. Now, what we typically do in C# world is probably, as we scanned each item, we'd be keeping a count of how many there were, and we'd apply a discount when we got to 3. But we'd need to keep that state of how many we'd scanned at each point. Or we'd need to keep a tally, and then when we wanted to get the total, we'd have to go through and count how many there are of each. But it's all keeping internal state. What we've done here by using reduce, and it's an important bit for both map and reduce, is everything we can do with map and reduce we can do with objects. We can do it with keeping states, we can do it with looping over keeping accumulators ourselves by hand, but these are convenience functions, and they also mean that we don't keep state ourselves, because it's all done as one operation by us. We do a map operation, we do a reduce operation. We're not holding on to the intermediate responses. Usually we actually even combine map and reduce together. Oftentimes in functional programming, something like Lisp or Clojure, Scala, or whatever, oftentimes, or F#, oftentimes people don't even keep assigning the intermediary results to variables. They will just embed the function calls in themselves and build up one big function, which you just pass your initial step to, and in a single move, as far as you see it, it just does a translation from initial to the end. But yeah, any questions so far?
Aren't you just, by adding properties to the object, the collection in that case, isn't that state?
In a fashion it is. By not using state, what I'm more meaning is that there isn't really state outside the realms of what would be a single operation that I perform to get it. There isn't state which other parts of the program can mess with. Particularly true in this case because it's JavaScript, and as Andy Larry pointed out yesterday, the way that even if you have other tasks running, they don't really run at the same time, so they can't really interfere with each other. So, yeah, if I actually just, like I've done here, I've called aggregate tallies. I've not actually used the results for anything, so they actually are immediately just, other than just displaying it here, they've then gone. But hopefully from those two examples there you can see map and reduce being used together. And this is kind of what the crux of map and reduce as a pattern is. You have a list of inputs, and then through repeated applications of map and reduce, you slowly just transform that list through a couple of steps from the initial form off into what you want in the end, by mapping things at each one and then reducing possibly intermediary steps of map and reduce. So you might map from one thing, reduce it in one way, reduce it a second way, take what you got then and map it again, reduce it, and just keep going until you finally get what you want. And that's kind of the crux of the map and reduce pattern. And it's a really powerful pattern, and it's very popular. Especially in the world of functional programming, where things are immutable and don't have side effects, which means that if things like ordering, especially on things like mapping on your list, your collection, I'll call it a collection from now on to go a bit high level. If ordering isn't an issue, what you can actually do is start parallelizing this. So a very common one, and you see this in Link, where from .NET 4 onwards, I think it is, from .NET 4 onwards you can actually do parallelize link, p-link, at which point if you just specify to do a link operation in parallel, it will split up your collection across multiple CPUs, passing off a section of each of it. Say you've got 10,000 results, it might split it across 5 cores, each of which will take a section of that collection, and after they've all acted on it, it'll then be combined back together again. And the same can be done with reduce, in that, yes, it can be split off. In that case, you do need to then usually provide some way of actually combining it together, but that is the crux of where Google's MapReduce framework, which they actually managed to patent for some bizarre reason, came from. Has anyone heard of MapReduce as the Google thing framework?
I've heard the name, but I didn't.
Well, basically, map and reduce is such a powerful pattern that Google actually took it and used it for a couple of years ago, when they decided to re-index the entirety of the internet for a new search engine that they'd implemented. They went, well, how on earth can we? That's the internet is huge. How can we do it? We can use map and reduce to basically parallelize that across thousands of computers in hundreds of data centers and re-index the entire internet before the heat death of the universe. So they came up with a framework, parallelizes, distributes across numerous computers and data centers, and just allows you to sort of specify a big old collection that goes in. It will then split it up across different data centers and as the results come back in, it will combine them. So you can actually have collections which are too big for any one thing to deal with. It'll split them up, boom, reduce, combine, and just keep distilling it down to a final set of data. I think I've not used it myself. Does anyone use Hadoop? Does it mention Hadoop as another
source implementation of it?
Yeah. Now, amazingly, even though Google were just applying an existing pattern with MapReduce, they somehow managed to get a patent off it, which is absolutely bollocks, because it's like someone like Google coming up with an IOC framework and calling it inversion of control and patenting it. It's just stupid. It's taking existing patterns and... But no matter, you can see there that the big boys use MapReduce, so it's got legs. It's been around for a long, long time. Do people... Would you feel comfortable, and I suppose this is the tough one now, actually using this yourself in real life? You've actually come across it... Well, like I said, select in C# is obviously equivalent of map. Aggregate, which many people probably haven't used, but also things like something like jQuery, where you use a CSS selector to get things out of by class name or whatever. That is then also generally building up a collection of some sort in jQuery, and then you then perform other operations on it, which is a bit like map again. And yeah, the Node boys have been using this because it's very common in nodes to work on things using map and reduce. Again, where are we for time? 4:10. Good. Boom. Which means that we do have time. Got 20 minutes to just quickly mention limitation in JavaScript. So the most obvious one, this bit here with the aggregate of tallies. Obviously, I've aggregated these away to a JSON. Unfortunately, right off the bat, map and reduce in JavaScript doesn't work on JSONs. So if I wanted to do further map and reduce on this, I'd be all out of luck. Whereas it's not unreasonable to want to use map and reduce over something other than an array. Anything which could be counted as a collection would be good to be able to do map and reduce across. Obviously in C# you do have the idea of collections, whether it's dictionaries, lists, sets if you're using something like nHibernate's is it Enum stuff, which has sets? I can't remember off the top of my head. But anything which is a collection should be fair game for map and reduce. Second limitation in JavaScript, it's not supported in some versions of Internet Explorer. Yeah. So it's there in IE 9, 10, 11. IE 8 and on, and beforehand does not have map or reduce. So you're all out of luck on those ones, or well, not quite, but out in some ways. Also, I think I read somewhere, I'm not 100% certain, and it's less of a concern, but performance in some frameworks is, in some browsers is perhaps, or some versions of browsers is not particularly fantastic for some things, but that's probably less of a concern now. Any other limitations in JavaScript? Can't think of any off the top of my head. But fortunately, as there are always in the JavaScript world, people have addressed this, and there is actually a library called Lodash, which is a library that adds whole reams and reams of functional stuff to JavaScript, including its own implementations of map and reduce, which defer to native implementations if they exist, or if they don't, it provides its own one. So Lodash will allow you to use map and reduce in Internet Explorer 8 and on upwards, and earlier versions of Firefox, Chrome, etc., which maybe don't have map and reduce, and actually adds in a whole shed load of others. So a common one, once again, it can be implemented with reduce, would be filtering. Filtering an array or a collection is a very common action. and you can do it with reduce, with the accumulator, and then just having passing in a function for doing a bit of comparison. And if it holds true, you add it onto the accumulator. If it doesn't, you don't. And then that returned list is the filtered list. It's such a convenience one that it's generally also included as a inbuilt thing. And indeed, it is in JavaScript. There is actually a filter function extension method on array, which does just that. You pass in a function which takes a single argument, no, 2 arguments, and just does 1 argument. Can't remember which. I have to check the documentation, but it allows you to actually filter an array into a filtered array. Other ones you might get, min and max, already talked about. They just use reduce, and in fact, map itself you could write using reduce, in that everything will always get stuck into the accumulator, but just transformed by a function. So Lodash adds huge amounts of stuff in. If anyone ever does any functional programming, it's well worth using. There's another library called Underscore, which I don't know if you've heard of. If you were in Rick Bolton's thing on Cohen's, I think it started talking about underscore at the end, which completely and utterly threw everybody, including Rick, who wasn't expecting it.
I think reduce might have actually done that, which might be why I was a bit
right.
vague remembering it.
Because it probably talked about reduce in the Cohen's, because it is a useful thing. And there was probably also then a brief mention that it isn't available in, say, Explorer 8 and before. So there's a library called Underscore, which gives that functionality. But Lodash actually takes everything that's in Underscore and adds loads more to it, and is actually backwards compatible with Underscore. They very deliberately started off just kind of doing a bit of a fork of Underscore. So it's 4:15 now. I think I've come to the end of stuff I was going to talk about. So just to wrap it up, does anyone have any questions or anything they want to ask? That's the same thing. That was a tautology there. Or anything they want to say, I meant. Do people think they get it? Do people still find it confused? Yeah, I thought it was a good idea, because often you see examples and they show map and they go, and here is a function which just squares everything, and there you go, you can see it maps. And here's reduce, and there's a function which adds everything together. There you go, you see reduce. And so that's brilliant. Yes, they do what they say on the tin, but it doesn't really show how you might use that in the real world. But yeah, there you go. That's the first steps. I'm not going to do the entirety of the checkout calculus, because I think that's, whilst it's certainly easy to do in just a couple more moves, it wouldn't demonstrate anything more really. It's just continuing combining of map and reduce. Yeah. So it's 4:15. Finished with plenty of time. Wrap up there. Thanks very much for coming.
Cheers.